speaking on open source, big surprise there. This is an X-ray of the scientific device known as the Antikythera mechanism. It's a combination calculator, clock, calendar, and orrery. It's about 2,000 years old. Despite a worldwide effort to try and understand its full capabilities, we can't do it. If we can't understand a science instrument of 2,000 years ago, how on earth are we going to understand today's science? In 2003, Alzheimer's research stalled. All of the drugs that they were trialling failed. In the first open science experiment, the researchers pooled all of their research data. 7 years later, we've got literally hundreds of drugs on trial at the moment. What I want you to take from this graph here are the number of different approaches of modelling temperature. Modelling is a really core part of science today. It takes a lot of code, a lot of computing power, a lot of data, and it produces a lot of data as well. Colab and organisations like Colab provide the technology to be able to share that code, the data and the results in order to make all of the models much more complicated, much more realistic. Modern science is extremely complicated and specialised. Most researchers only know their own discipline. This map by the Public Library of Science shows the interconnections between the disciplines, and they are trying to connect researchers from different disciplines and get them to work together to find synergies in their related works. CCAN is a really interesting project. They try to automatically discover relationships, correlations, serendipitous knowledge automatically in disparate data sets. Open Notebook Science, this is a set of licenses that researchers can use on their work. It's very similar to Creative Commons licenses, but for research work. This is the Open Knowledge Foundation. They are an umbrella group based out of the UK. They've started a lot of the projects that are at the core of open science now. Their main aim is to try and convince researchers to do open science. A very interesting organisation. This is an Indian organisation, and their core goal is to make cheap, effective drugs. In Australia, one of the organisations is ANS, the Australian National Data Service. Their main goal is to create a catalogue of all Australian research data. So when you get a research grant, instead of spending all of your time doing tests, you can use other people's data. IMOS is another Australian group that make marine and weather data from thousands of resources freely available to climate researchers around the world. The Personal Genome Project is an American project. Members of the public can get their entire DNA sequence mapped. It's made public for researchers all around the world to use. There was a lot of hype when we first started figuring out how to work with genes. There is still a long way to go with that, but we are starting to see some positive results. In Australia, one of the interesting things, if you give blood and for whatever reason your blood goes stale before somebody can use it, often that blood then goes on to be used by researchers. And there's a lot of interesting stuff that gets done through that. Distributed computing, SETI at home, the search for extraterrestrial life. Distributed computing is the way that a lot of this stuff is getting done now because the models are getting too complicated to do on one system. Folding at home, another distributed program, looks at how proteins fold and unfold. There are a number of diseases where when a protein folds incorrectly, bad things happen. Einstein at home, another distributed computing project, also looks at astronomy data. they've recently had quite a few successes discovering pulsars and other oddball objects out there. Thank you.